Good morning students. Today we will discuss about the path of light incident on a transparent medium, a triangular glass prism. Before we go into the discussion, let us recap few important points. What is the cause of refraction? What happens when light passes from one medium to another? Yes, bending takes place because the speed of light changes from one medium to another medium. What happens when the light passes from a rarer medium to a denser medium? The light will bend towards the normal, and we know that when it passes from a denser to a rarer medium, it bends away from the normal. Now, let us see how a two-dimensional view of the glass prism looks. We can find two triangular ends in the green color and three rectangular sides in the blue color. Now, the three rectangular surfaces are known as the lateral faces, and the two triangular ends are known as the base of the prism. Now, when you fold along the edges, you will be able to view how a triangular glass prism looks like. So, when we fold along the edges, we will get a model of the triangular glass prism like this. Now, consider two rectangular surfaces of the glass prism. We can find that they are inclined at an angle. It is denoted as angle A in the figure. This is known as the angle of the prism. The two opposite rectangular surfaces that are inclined at an angle are the refracting surfaces of the prism, where the light incident on the prism on the first surface undergoes refraction, passes through the prism, and once again undergoes refraction before emerging out of the prism. So here, when light passes through a prism, it undergoes refraction twice. Any one of the triangular surfaces can be taken as the base of the prism. Now, we will learn an activity to know the incident light path, like when it is incident on the glass prism. How exactly does it pass through the glass prism and undergo refraction? For this, we will study an activity. We need a triangular glass prism, a sheet of white paper, a drawing board, 8 board pins, a sharp pencil, and a protractor. First, take the white paper, place it on the drawing board. Fix the paper on the board using 4 pins. Place the glass prism on the triangular base in the middle of the paper, and then you trace its outline. Name the triangle as ABC after removing the glass prism. AB and AC are the two refracting surfaces of the prism. Now, consider a point E on the refracting surface AB. At this point E, use a protractor and a scale to draw a normal n dash and an incident ray making an angle of say 40 degrees with the normal. So here at this point E, you're drawing a normal n dash and an incident ray making an angle of 40 degrees with the normal. You can find the incident ray in red color in the figure. Now take two pins and place them upright on the incident ray, that is perpendicular to the surface of the paper. Place the prism back along its outline and try to view the pins placed on the incident ray from the other refracting surface AC of the prism. You have to view the pins that we placed on the incident ray from the other refracting surface AC. You will find the images of the pins placed on the incident ray. When you look through the prism, we can find the images of the pins. Now, we need to place two more pins from this position such that the images and the pins that we are going to place are along a straight line. Now, after placing the pins, remove the glass prism and the pins. Mark the pin points on the incident ray with P and Q. And the pin points of the pins that we placed on the refracting surface AC as R and S. Join the pin points R and S to meet the refracting surface AC at F. At this point, draw a normal M dash. M dash. The ray FS is the emergent ray and is shown in red color. The angle between the emergent ray and the normal is the angle of emergence E, small e. Join EF, E on the refracting surface AB and F on the refracting surface AC. EF is the refracted ray through the prism. This is also shown in the red color. The angle between the refracted ray EF and the normal EN dash is the angle of refraction denoted by small r. Now, extend the incident ray by a dotted line to H. This would be the path of light if the glass prism is not placed. By placing the glass prism, light gets deviated by an angle and is bending towards the base of the prism along RS. Now, we have to produce this emergent ray RS back to meet the incident ray at G, to meet the extended incident ray at G. The angle HGF is the angle of deviation for the light ray incident on the prism. This is the angle by which the incident light gets deviated from its path on passing through a glass prism and is denoted by a capital D. While doing this experiment, remember a few precautions to trace the path of light through the glass prism more accurately. The glass prism should be placed exactly over its outline drawn. Pins are to be placed upright to the surface. The last one, we should avoid parallax error while viewing the images of pins through the second refracting surface of the prism. So we have seen how the light gets refracted on passing through the prism, and we have also learnt what is angle of deviation for a prism. Now we are going to learn the factors that affect the angle of deviation. There are 4 important factors that will affect the angle of deviation: the angle of incidence, the angle of the prism, the material of the prism, the color or the wavelength of the incident light that we take. If any one of these factors are altered, the angle of deviation also changes. So now we will see a comparison between how a light ray is getting refracted when passing through a glass slab and how it is getting refracted when it passes through a prism. In a glass slab, we have seen that the emergent ray shifts parallel to the incident ray. But in a prism, the emergent ray is deviated by an angle. I'll repeat. In a glass slab, the emergent ray shifts parallel to the incident ray, but in the prism, the emergent ray is deviated by an angle. This is because the refracting surfaces of a glass slab are parallel to each other, whereas in a prism, the refracting surfaces are inclined at an angle. That is the reason why it gets deviated by an angle in a prism and is not shifted like in the glass slab. In the next module, we will be learning about dispersion of white light by a prism.